Hello. Welcome to FORA 2022. Thank you for your contribution to our Congress. There are nine presentations in this session. The maximum duration for each presentation is 15 minutes. All presentations are recorded. It will be broadcast on YouTube after the Congress. First presentation, Atel Sabih Shakir. He is not online. Dear Yasemin.
Assalamu alaikum.
Alaikum salam.
My name is Yasemin Kudayer. You mean me or another one?
You can share your screen.
Okay. That's okay?
Yeah.
Okay. Assalamu alaikum. My name is Yasemin Kudayer. I am a master's student in Karbala University in Iraq. This presentation showed the basic outlines of the survey that I published about wireless sensor network routing protocols that proposed by many researchers in the last few years. The title is A Mixed Hierarchical Topology to Ameliorate the Efficiency of Wireless Sensor Network. First of all, the performance of hierarchical routing protocol is so important. In wireless sensor network, the most researchers present a comprehensive reviews about the routing protocol and the topology. So the wireless sensor network is it consists of a number of sensor nodes that specially distributed in a specific area to monitor physical or environment conditions such as sound, temperature, pressure, and communicate with one another to collect all sense data and forward it to the destination, such as sync node base stations through the network infrastructures. The most of the performance of wireless sensor network and the metrics that we compare with each other, such as latency, delay, energy consumption, and deviations with the other one. All the researchers try to improve that drawbacks in each of routing protocol. The most of and the important routing protocol that I mentioned, such as LET, Pegasus, and deterministic chain-based routing protocol and direct line routing protocol, that all used different topologies to improve the performance of wireless sensor network that used in most applications. The most outlines wireless sensor network characteristics, routing protocols, and literature reviews of the most important routing protocol and conclusions. Wireless sensor networks consist of basic nodes. The sync node at base station is usually one stationary node that is the destination that all the sense data collected by the sensor node delivered to the base station through leader node that is called usually chain head or cluster head. and all the sensor node that is hundreds or thousands that is distributed or deployed in the environment randomly or deterministic, depending on the routing protocol proposed by the researchers. Sensor node content are 4 units: sensing unit, computing unit, and communication unit. And all that unit are supplied by power unit, that it's one. Power unit is the basic energy in the sensing node that's usually fixed size. The characteristic of wireless sensor network. The communication between sensor node is very important topics because it increase or decrease the network lifetime by consuming more energy and a lot of delay in transmission of packets to the sync node that called base station. So the main objective of wireless sensor network is to reduce the energy consumption and reduce the delay. That is the most two drawbacks that all the researchers try to improve it. The communication that shown in the figure, 3 figures, A, B, and C, that is the communication between nodes are multi-point to point and point to multi-point. And the last one, C, is point to point. And the basic equation of transmission, k-bit of data, and receiving the data between sensor node are the equation 1 and equation 2. That is the using the energy, energy remaining in the node or the energy consumptions. And the method of communication between base station and other node in the networks is used the first order radio models to transmitting the signals that it's ready to send its buckets. Then the most important thing is the deployment of the sensor node in the environment and the topology that used to build the wireless sensor network. That topology called routing protocol. There are 3 types of routing protocol: flat routing protocol, hierarchical routing protocol, and location-based routing. The most important one and used very widely is hierarchical routing protocol that is divided to cluster-based, chain-based, tree-based. Each one of that 3 types has its disadvantage, and many researchers try to mix between 2 or 3 of them to improve the performance of the networks. In the next slide, I will show the 3 types. That's the older one that proposed to each type. In 2030, DRINA is the routing protocol that proposed by Vilas that distribute the sensor nodes randomly. We can show that you can observe that the sensor nodes are randomly with various distance between each other and its neighbor, and connected the node and its neighbor as a tree from the furthest node, the child node, to the father and parent and connect to the sync node base stations. And the example of Pegasus is the routing protocol proposed by Lindsay in 2002 is formed as a chain of nodes. The farthest node is connected to its neighbor and connect to one elected leader node that called the chain heads, that collect all the sensed data from the all sensor node to them and deliver it to the base station in one single hop. But all the sensor nodes are connected just to its neighbor. This because it has a lot of drawbacks. The main drawbacks is delay to deliver the sensed data because of the long single chain. In ledge routing protocol, This is proposed by Handy in 2002, that is improved of the Pegasus, is divided the sensor node into clusters. It uses k-mean or nearest neighbor algorithms in AI to divide the sensor node to clusters, and each cluster has one leader node that called a cluster head that collects all the sense data from the sensor node to the base station. It has also a drawback that it had delay, but it's better than Pegasus. Because it has 4 or more than leader node that elected in each round cause delay and less energy from Pegasus. We can notice that all sensor nodes are randomly deployed. So there are 2 methods to deployment method of sensor node. One of them is randomly and the other is deterministic. Randomly, which means that all sensor node is published like in military, that in risk area. So, and from the airplane, they drop all the nodes with not a specific position to it. But in deterministic, that it's used in a lot of safe and not risky areas. Deterministic node, that all the distance between sensor nodes are fixed. This kind of routing protocol that use deterministic deployment method has advantage such as less delay, less energy consumption, and easy to coding in the simulators. So in the next slide, this table shows the most routing protocol proposed in the few last years, starting with Pegasus, Ledge, and all other routing protocol are performed proposed to improve the Pegasus and Ledge. We can show that BDCH is used to improve Pegasus that has a branch chain and double leader node to reduce the energy of Pegasus. We can show that there are deterministic, such as 2-stage cluster-based, reduce the energy consumption using chain hierarchical chain based, using horizontal and vertical chains, using a greedy algorithm to communicate the chain and build the chain of node, that it's used deterministic. We can notice that there are deterministic, CCM deterministic, it's in using a randomly election of the routing protocol. The election of leader node is very important. So the most contribution of the researcher is to contribute an equation to elect the cluster head or chain head to minimize the delay and to improve the performance of wireless sensor network. And the last deterministic chain-based routing protocol proposed by Haider Marhoun is improve the energy depletion and shows more performance than other energy routing protocol proposed using chain cluster, and the CCMIR is used to cluster and chain mixed of 2 topologies in one routing protocol. So I try to explain quickly because of the time. The performance metrics that is used in conclusion, all the researchers try to show its performance of its routing protocol by comparing with other using performance metrics such as delay, end-to-end delay, energy feed and delay, and energy consumption. And network lifetime is the most important performance metrics. And thank you for your patience. Thank you.
Thank you for presentation.
Thank you.
Next presentation. Dear Fadel. Dear Fadel Kadom Jabor. Okay. Dear Mohammed. Mohammed El Heiti.
Hi,
What's paper ID?
it's voice encoding for wireless communication based on LPC.
ID?
Sorry,
Paper ID. What's paper ID?
it's I think 181. Just 1 minute, please. It's from yesterday.
Okay. Okay.
Yeah, 181.
You can start.
I don't know. It's I think it's there's problem with my PowerPoint, so I will use as a PDF. Okay.
Okay. What's your name?
Muhammad Al-Hiti.
Okay.
Shall I start it?
You can start.
Okay, thank you, and thank you for your time. Voice encoding for wireless communication based on LPC, RPE, and CLP. So nowadays, voice encoding are one of the best elements in the multimedia and telecommunications. This is a report or a paper explains the properties of speech, how sound waves are generated, and how they are classified, and what is voice and unvoiced speech. So based on waveform encoding technique plus pulse code modulation, that's mean PCM, and introduced and as the most common technique by changing the analog signal to digital data. Three types of voice encoder: linear predictive coder, LPC, and regular pulse excited RPE, and the code excited linear predictive CLP. Are briefly discussed with the performance conversion table between them, and the made to give a different summary. So now, introduction. Nowadays, one of the most important factor in wireless communication is the voice of the objective voice coding is to computer and pressure speech signals to how bitrate transmitted, with protecting the important features quality which are necessary for specific applications. So the voice speech is mentioned above, as you see in this picture. It's the heart health and nasty curvy and lips to tongue and others. So when air pressure which come from the lung force to the vocal cords to open as oscillator. The vibration frequency parts change from 50 to 400 hertz. That depends on the several things such as the person's sex and age. That means there's a difference between women and men hertz. The produced resonance in the voice path at the signal harmonic, the peak of the resonance and named format. Unvoiced speech. Unvoiced speech sounds are generated when forcing air over an open named force or art product and first don't create many precedent on a voice because it does not oscillate the voice chords speech. General encoding of waveform is very important to encode the waveform by converting it from an analog signal into digital form. In order to predict the good quality, waveform code are typically used at a high bit rate. There are several examples of the general encoder content fields code multimedia. That means modulation. That means PCM for the telecommunication and information and form binary coding by music compact disc. The most common technique used to change analog signal to digital data is called pulse code modulation. It's one of the wave encoder technique that you use in a popular voice right circuits. The PCM encodes a high bits per sample at 8 kilohertz sample rate. So the minimum bandwidth wanted to the 64 kilobit per second, and the bit rate value is also equal to 64 kilobit per second. That's the process of the saving bandwidth isn't considered an efficient. Also, this is a process isn't visible through the communication channels in case that the bandwidth characters is phenomenal. Types of voice encoders: digital voice common use system use vocoder to minimize transmitted bit rate by the compressing speech signals and shown in figure 2. So in figure 2, decoder and config is analog to encoder and change digital to analog and encoder encode the analog to digital decoder P. These parameters are voicing gain filter, coefficients, bandpass period. So LPC, it's the most popular technique, which is used as speech coding at low bit rate. And the second technique which are REP, that's regular pulse excites. There is another type of hybrid coding. It's full right linear predictive coding, regular pulse excited. This type is used for product a balance between data rate and the quality of GSM network. As the traditional PCM, the similar sample rate is 8,000 sample over second. Is used to represent the input source, which contains 13 bits for each sample. There are several important steps are needed to generate 13 kilobits per second. Firstly, the input sample are divided into a block, and each block contains into 160 sample. After that, it's applied to a short term of LPC, where 36 bits per block is out of the filter of LPC. Those blocks are split into 4 sub stage for 40 samples, and provide that to LTP, long-term prediction filter, to get the coefficient to represent the pitch gain and period. The overall is 36 bits for 160 samples, due to each sub-block represented by 9 bits. So the third type is called excited linear prediction, CLP. There are many attempts to improve the extended LPC coder, and the first idea of the code excited linear prediction, CLP, was created by Skoda and Attel in 1985. So it's one of the most efficient coding method at low bit rate, that the gap between vocoders and waveform code could be bridged by the production low rate coding speed, which is done by CLP algorithm, similar to the medium wave rate. So now the fourth, the performance comparison. If we show the main difference between LPC and RP and the CLP coder, LPC, RPE, and CLP data rate, the LPC 2.4 kilobits per second, and RPE 13 kilobits per second, and CLP 4.8 kilobits per second. The distinction between voice and invoice, LPC is uses switch, and RPE uses regular spaced calls, and CELP identified voiced and unvoiced speech. For the speech quality, LPC poor, and RPE is relatively good, and CLP very good. So to sum up, it can be clearly seen that the transmitted digital voice has many important benefits. Much between bandwidth can be saved by pressing the signals and decreasing the bit rate. BCM was the first encoder design to achieve like a transmission. The performance of the different encoder are commonly compared by considering the voice equality data rate and intelligibility. DRT and the MOS technique are used to measure the quality of coder. MOS is the most frequently method used to several modern type of voice encoder. LPC, REP, and CLP are explained, also of their low data rate operators still depend on them. And thank you for listening.
Thank you for presentation. The next presentation, Fadel Kadom Jabor. Dear Fadel. Dear Fadel, can you hear me? Okay. Anyone not presentation? Okay. All presentations were completed in the session. The session to end. See you next session.
Excuse me, just my presentation.